Hey everyone, I'm Julien again. For those who've been staying in this stage, I'm doing another round. Um, so what I'm going to talk about is rendering. That's what I do for most of the time. Um, First, what I have to say is like the name of the slide seems like I know where I want to go. That's really not the case. Um, First, awesome. So first, I think there's several direction we can go into, and we definitely should try to explore as much as possible. Why do I think this is good? Because rendering architecture hasn't evolved that much for a long time, and we live in a completely different world than when rendering was originally designed. So I'll try to present a lot of ideas. Some of them I'm involved in, some of them I'm just like kind of a bystander and I've kind of been on the side hearing about it. If your idea is not here, feel free to like, hey, or at least at some point interrupt me and you can always present your idea. So first, why do we want to change rendering? Well, I kind of gave the answer already, but I think it's like because we can. That's pretty much what it is. It's like a lot of the constraints we used to have are just gone. And I mean, it's a good time to actually start experimenting with alternative designs. Some of them may be worse, but at least we learn something in the process. For some of those who've been involved or have been following the lazy block idea, this is something that didn't pan out in terms of code will actually ship, or at least that's my understanding. Other layout gurus can interrupt me here, but at least we learned something in the process that we've kind of backported to the rest of the code. But more seriously, why do we want to change? Well, you've heard this word over and over and over again, so I'm not going to say it. But there's a lot of other stuff that are coming. Rendering is, and a lot of the core directory is very, very much tied together, like glued. Rendering talks to HTML, talks to SVG, talks to the loader, and they talk back to rendering. I mean, like, rendering is exposed everywhere and shouldn't be. That's why modularization is something we should definitely look at. Code quality, well, anybody who's actually like tried something in layout would know that we need better testing. And I can add more feature. Well, feature are coming. There's some of the architecture is actually limiting us. And I'm going to talk about that a little bit more in detail. So first, well, performance. Memory trade-off. There's been a lot of talks, at least a lot of folks that have said that the render tree is actually very tiny, especially if you compare it to a texture on the GPU. And this is something I don't think anybody has really dug into. Like, what happens if we make render object bigger? Do we regress 5%? Do we regress 50%? Nobody knows. But if we add some information about that, we could do different trade-offs in terms of memory. Like, do we need a rare data map anymore when we know that memory is not that much of a problem? An example that is really core to actually rendering is like heat testing. And do anybody knows what heat testing is first? Okay, let's see. Yeah. Heat testing is just clicking on something. We have to determine actually what did you click on, which element you did. Heat testing and painting are big O of n being the number of nodes in your render tree. It doesn't depend actually on the size of your screen. So if your screen is actually tiny and has like one element on it, but is gigantic, then we'll be super slow. Whereas if we had a smarter data structure, we could probably do a better job. Layout has been mentioned as like one of the most slow operation, I guess. a lot of times. How can we speed this up? Maybe there's better data structure we can use. What I didn't mention here, which is actually super important, and I will come back later, is render layer. For those unfamiliar with this class, I'll dive a little bit in the details, but render layer has also been spotted as one of the bottleneck in some of the operations. But I will explain a lot more about that later. I have my shtick about render layer. What you have to see, what you have to see is like when we draw operations, we end up recording them in skpicture. So that's one of the crazy ideas. Like, okay, skpicture is this flattened out tree representation that we actually send to the GPU. And the GPU replays it back, and then that's where we got the pixels. But then why do we need to use an skpicture? We already have a tree. Why don't we just send the tree directly to Skia? Or find a way where Skia could accept a tree-like structure directly that we don't have to marshal, and then let them do the painting themselves, or like swap trees around, or like there's all sorts of different design that we've been talking about, because what you have to see is like Skia does a lot of operations in the background because we're sending it this flattened out kind of dumb comments through skpicture. Sorry, is everybody familiar with skpicture? Okay, skpicture is a deferred, is basically a comment buffer. So when we say, hey, please draw a line here, Skia just record the operation. So draw a line from like 0, 0 to like 0, 50, records that, and then we'll replay it back later. Yeah, so yes, this is like a display list, indeed. What happens is we do a lot of operations that are needed, and Skia has to be smarter and has to do some look ahead in skpicture to like say, oh, you're pushing a clip here, you're doing nothing in between, and then you pop a clip. So basically between those two, I don't need to push and pop. Skia needs to do a lot of stuff in the background because we're basically sending it this intermediate representation. So some people were saying, how about we evolve it to something else? Now modularization. What you have to see is rendering kind of sits between the compositor that gets, that kind of drives the painting and the rest of core. And we don't have a good interface between those two. The interface for compositor is kind of at the render layer level. So I should probably explain what render layer is. Render layer is a very old object in rendering that basically was used in the old days to do just only opacity. If you have to think of it right now, it's like any operations that should be applied on a group of objects will require a render layer. The problem is it used to have a meaning back in 2005, and nowadays it's more like a dumping ground for anything that you think would apply to a group of objects or should basically be rare, which I don't believe anymore. But so render layer is very central to rendering and is how the hardware acceleration was hooked on top of render object. Graphics context. Graphics context is like the low-level API that we use to communicate with Skia. Back in WebKit, graphics context used to kind of represent the minimal API subset that was supported throughout the platforms. Because graphics context basically mirrors whatever platforms WebKit was implemented on top of. Because it's a minimal subset, it means that it doesn't really match what Skia can do. And if you make graphics context smarter or just remove it and use Skia straight ahead, you may have more powerful APIs that are currently unavailable. One example of that Darren mentioned this morning is a rounded rect. In WebKit, this is like 8 operations and a hell lot of function calls. In Skia, you have like one API that is basically escape path add rounded rect. And Mike Reed from the Skia team was like, you want a rounded rect? Why do you tell me draw a line, draw a path, draw a line, draw a path 4 times? Why don't you just tell me draw a freaking rounded rect?
Is anyone making changes in this area?
So the question is anyone making this change? Are you signing up for it? We're talking about that. This is probably a low-hanging fruit, really. Like graphics context is like, if you come here and start like taking around stuff out of graphics context, people would love you. But as far as I know, no one actually is doing that right now. Now I'm switching more and more on the code quality side. Anybody who's done like serious rendering work knows that the render tree and rendering in itself has a lot of hidden contracts. And if you break them, usually it's bad, like really, really bad. Like Inferno would go after you usually, that kind of bad. We've started to do a little bit of peppering assertion around so that now you know we make them explicit so that the next time you come, you don't basically trip them over and over again. And we had a couple of good success stories so far. One of the good example we had is Philip over there in the back hiding landed finally an assertion we wanted to land for years, which is at the end of layout, you should never ever let a render object needing layout. Sounds stupid. Well, it tripped on like 3 or 4 tests, and now we're down to 1. So, and Florine, I think, signed up for the last one. Hopefully, we can get rid of that for good. Yeah. There's like all sorts of like crazy stuff. Basically, one of our contract, and we're trying to enforce it, is if you do layout or painting, you shouldn't touch the tree. You shouldn't mutate the tree in any ways. Believe it or not, this trips. We still have to investigate why, but that's the kind of like very low-hanging fruit that anybody touching rendering for a while understands, yet it doesn't work. Now, if we continue into into code quality, definitely testing is there. I like to think of layout tests as your safety net, as more or less smoke tests. Like, I haven't broken everything, but usually you've broken something, especially if you touch layout. Our big problem is we have a lot of tests, but they're kind of integration tests, so you can't really say how much of your code is actually covered. There's like branches of the code that are just not tested at all. Like, I know I've worked on table for a while. It's like tables is just like, okay, you touch it, you're gonna break something. And all the tests pass, flying colors, everything is fine, until like you get 3 regressions filed against you. Repaint test, my favorite. I have a slide about that after. We have about 250 repaint tests. Repaint is everywhere. Like, repaint is when you like, oh, I moved this div from here to here, I need to repaint the old position, the new position. Well, we have 250 tests for that, which means pretty much it's uncovered. Something I would be super excited about is unit testing. We do have a tiny bit of unit testing, but basically currently rendering unit testing is let's bring the whole Chrome stack, create a DOM, and basically from this DOM, get the renderer and then ask the renderer a couple of questions. But that still means you're basically invoking the whole Chrome stack. and loading an artificial page. This would definitely require us to have an interface, and hopefully this we could get that running. Plus, that's something I would like to work on, but haven't been able yet. Speaking of code quality, those are like I'm missing one that's coming after my favorite. Runner block, giant, runner box, giant. Runner block is actually a good example because actually runner block is actually two concepts bundled in one class. It's actually what CSS called a block flow. Yeah, it's a block flow and a containing block at the same time. Those two concepts, which are kind of separated in CSS, are kind of like bundled together in one class. And we've been talking about like how do we split runner block into those two classes, so that now we have the block flow, which kind of floats, which has a line layout, versus the block itself, which is the containing block, and what most of classes inheriting from block are actually interested in, like render grid, render flexbox for flex, inherit from render block, but that cannot have any floats. Yet we basically get all the logic from block for free. And all the renderer classes are just gigantic as a whole. So my favorite class, render layer. For those who've been at last year WebKit conference meeting, I was pretty much heads-on on killing it. A year after, I'm still there. I haven't really been able to move on the WebKit side, but I'm making some progress on the Blink side. So render layer is one of the big problems of render layer, apart from like being nearly as big as render block, is also that it has a lot of different functionality, and some of them SVG would like to get. The example being z-index. Z-index is something SVG would like to support. This is what render layer provides. But they don't want the full render layer because render layer involves a lot more craziness than they're willing to accept. The other problem is because render layer is one level above render object, it doesn't have all the information render objects have. So one of the good example that's killing us right now is you do a layout. Layout would repaint everything, and then render layer would come. And because render layer has no knowledge of actually who has been laid out, it will recompute all the absolute rectangles inside render layer without knowing that actually there was no need to do that because you didn't get laid out. If you don't get laid out, you cannot have changed your size. So that's why I'm pretty much set up on like, we need a way to like kill it and replace it with something smarter. Smarter being probably involving render object themselves because they already have all the information you need. So that's something I'm actually working on. Hopefully I can get something done. Repaint. Oh, talking about features. So repaint is about like you have 5 different ways to do a repaint. From like straight CSS invalidation, where you just call one method to repaint yourself, to render layer is actually involved in repainting, to like during layout, we check if you moved, and if you moved, we repaint the old and the new position. There's like all sorts of craziness. Repaint is broken with 2-pass layouts. That's by design currently. Like, so 2-pass layout is the example of tables. Tables needs to lay out the cells first. Once you have your cell height, you know your row height. And once you have that, you need to relay out again because maybe your row was constrained in some ways. So that's how table layout basically ends up relayouting some object twice. And because of the way repaint works currently, we basically don't repaint properly at the right position. We end up like invalidating a lot more than we should.
Is that because you invalidate the parts of the first class as well as the
Okay, so the question is it because we invalidate after the first pass and then again after the second pass? Exactly, sir. That's exactly our problem, is we track the old rectangle before the first layout. After the first layout, we're like, oh, we're finished. We repaint the new position, which is a temporary position. And then we do a new layout where basically it moves again and we just repaint again. Yeah. Ojan, which I don't know if he's around, was actually talking about changing that for good. We talked about doing things differently that would make this actually work properly.
Sorry, I was listening.
Thanks, Ojan. So it's about the two-pass layout. You were reaching out last week about it.
Yeah, so right now, when we do two-pass layout, we do this thing where we like repaint after layout it moves, um, and the proposal was to, at the beginning of the two-pass layout, save all the like old recs, do the layout, and then do the repaint all at the end. Sorry, I'm not describing this very well. In short, to do repaint validation, you need the old rect and the new rect the same. And a two-pass layout, you don't necessarily know that. I don't know. So,
Well,
I'm sorry. Is it correct to say that what you want to do is invalidate the old recs because that's where things used to be and now they're no longer there, and that's reasonable to use before we begin the two-pass layout, and the new recs just don't need that intermediate between the first and second layout passes. What we really want is to skip that and only get the new recs after those passes. Is that what you're saying? Yes, mostly. Right now we don't invalidate the old recs at the beginning. As I think about it now, I'm not really sure why.
probably a bug.
But it's not as simple as that. Is it because as if you can have a two-pass layout for a table, but you can have some other parts of the document that will lay out correctly in the first pass?
Oh, sorry, I know why. The problem is if the thing didn't move, you don't want to actually invalidate the rest at all because you don't want to repaint because the thing didn't move. So you have to do it all at the end. But in a two-pass layout, we'll lay it out once over here, and then we move it, and we lay it out a second time over here. We don't care about that layout. We care about where it was before the first layout and after the last layout.
Okay. So if you heard. I kind of fit in that code sharing with SVG is also something we should try to do, even if the two models are very different, but they're probably something we can do. Z index being one. I know SVG also want hardware acceleration. Hardware acceleration, remember, is currently dependent on render layer. SVG has no render layer, no hardware acceleration. Yeah, hardware acceleration everywhere, ideally. And that's pretty much the end of what I had to say. If I missed something.
Yeah. I think one big one that we should mention, hopefully things work out and we can solve something like this. I don't know. But incremental updates. And what I mean by incremental updates is the idea that, so I like to say that there's two dimensions to incremental. One is that there's various phases that we do on the whole render tree, layout, style recalc, compute compositing requirements, and phases within those phases, that we don't need to do all those phases. We can skip them when we recognize things don't need to be recomputed. And the other dimension is the same thing, that we only need to recompute things for the layers that we know that we need to recompute them for. And it's a little bit tricky because things that change may affect ancestors and may affect descendants. But I'm personally hopeful that we can get to a state where if we can clearly define how how such an incremental update architecture would work for kind of the whole pipeline, that maybe we could look at what we have and where we need to go to get there, and it might be possible for a long-term thing that's really expected.
Okay.
That's kind of my ideas.
We definitely do a lot of work. If we could be a bit smarter about it, that would help. Yeah. We mentioned render layer not being doing way more extra work than it should. Yes, Tony.
One of the problems I think has been brought up on LinkedIn recently that I think is a big problem that I've noticed is that we lay out too much too often, and like something that moves over here affects the entire tree. And so I'm wondering, we all have ideas for how we could change the web platform so the web developer could isolate parts of their layout. But I'm wondering within the current web platform, what are our levers, and do you think we have any ways to better isolate layouts so like touching one part of the tree, we can automatically determine that it doesn't affect another part of the tree. Do you have any thoughts on that, or maybe other people in the audience?
So I've thought about that a lot. We need to see the microphone. The
Yeah.
problem is there's not much we can do that real world pages do. I'll just get up. I was saying the problem is there's not much we can do that real world pages actually do. For example, if something's like overflow clip and doesn't have any position descendants and is fixed height and is fixed width, then we could do a thing where we know that the contents of this overflow hidden div, like the layout of the contents can't affect the layout of anything outside of it. And then we could do a thing where we just do like this partial layout of just that subtree. But then that set of circumstances is pretty rare, right? We detect something like that. Sorry, he said WebKit and Blink already do this. Right. Yeah. Other than that, I haven't really come up with like cases where we could better separate out layout. Right, you should come talk about it. I can talk about it. Philip, who just said that, is working on partial layout, which is like when script accesses offset top. We don't actually need to lay out the whole document. We just need to lay out up to the element that you accessed offset top onto. So Philip is changing render block so that we can abort halfway through once we've hit that element. And then we still need to do like a full layout in order to do a paint. But if you're like in some loop doing JavaScript, grabbing offset top on all these different elements, then we do less work.
That sounds really awesome. Do we know what other browsers do in this regard? Like, have other people already applied these optimizations, or are we?
Philip should just come up here and talk about this.
Yeah, I thought Mozilla was actually or add like partial layout.
So the idea to do partial, I don't need the mic. The idea to do partial layout was inspired by something Mozilla already does. And in fact, I think they even do it for paint, which is a little weird because you could get inconsistent paints. We're not going there yet. we'll do just the thing that we know will work, which is the offset top thing, or the access from JavaScript thing. And then once that's there, we can play around with it and see if we can do partial layouts with paint. Because in theory, right, you don't need to lay out the stuff that's not visible. That's like out of even like our estimated paint region. Right now we lay out everything. In theory, we could not. Yeah.
That's the tricky problem.
That's what I was going to say. A lot of that you can detect at salary calc time, right? If the thing isn't position absolute or fixed or whatever, we know that at salary calc time.
I have a question. Is it meaningful to brainstorm the idea of a sort of like a delta-based approach where we have the notion of a style diff, and if there's some way we can conclude what implications that has on layout in a kind of like encode things as changes to layout rather than having to recompute a static state of layout. I have no idea. Is this a meaningful idea?
I mean, we already do something like that. For example, when you like move a position absolute, we do a cheaper layout. There's the simplified layout that we do. So in at least in the easy cases of doing that, we already do it.
Yeah, another idea is record all the things you did during the layout and apply them at the end. And you can, instead of like repeating all the things during the layout, you can analyze the string. It's similar to how sketch would work. Instead of like setting the left and the width and all the other things, we just record them in a buffer. And at the end, we can analyze that how what we did during the layout and just do that instead of doing it all during the actual layout. So you can do some sort of transactions.
Yeah, I believe that's what layout delta does to some extent, but we use them during layout. We don't keep them after.
A little intrigued by your comments about fit testing fading the order. Do you have anything, this is more a question for Tommy, I guess, in telemetry that measures pages for lousy hit testing?
Okay. The question is, it's kind of interesting that hit testing and painting are like linear in terms of the number of render tree. Do you have any testing for lousy pages or big pages, basically, in telemetry?
For hit testing.
For testing.
Yeah, so hit testing has a trace event around it right now. So when we rerun this experiment with tracing instead of timeline, we'll be able to see how long we spent in hit testing. And we can also look at the list of the slowest sites for hit testing, so we can get an idea of the pathological cases out there. I think, I'm not sure if I quite understood the question right or not, but the other interesting thing is like, how do we find n-squared cases? So I think this other interesting experiment is like comparing time we spend in layout versus number of nodes in the DOM or some other metrics like that. Like Eric Seidel, as we're just talking about after the meeting, how do we find paint storms? So like the graphics guys were talking about with paint storms, so maybe we do something like number of paints versus number of pixels scroll or something like that. So I think coming up with experiments like that is a very good idea. We should like brainstorm how to tease out these pathological cases that we can optimize.
When telemetry runs, does it it like puts the mouse somewhere?
During the smoothness measurement, it keeps the mouse in the center of the screen, and then you can also tell it, I want the scroll to happen here or there. And so on like the reported top 25 sites that we have, we know that like for Gmail, the mouse has to be here, and for calendar, it has to be here.
Mm-hmm.
But when you're running like the top million site, you're just gonna have to do something like do the center of the screen and hope you get the interesting scrollable region.
I'm just wondering. So we'll actually hit the hit testing code.
Yeah.
Yeah. Right.
Okay, if there is no other question, thank you for your time.